Hello and welcome to my YouTube channel, this is Ramani Online Mathematics. If you know you have not subscribed, subscribe for me and share to your colleagues. Thank you very much. Now we are going to look at the canonical form. The previous video we proved the formulas. Don't be thinking about the formula too much, okay? It's not something that you have to memorize it or chew it just like that, no. Okay, so now let's look at the first example. Write the canonical form of x squared uxx plus 2xy uxy plus y squared uyy equals 0. Okay, now for what I'm going to do, just like I did for the first order when I was using the method of characteristics, we looked for the linearity. We solve example under that one using the method of characteristics, the quasi-linear, the semi-linear. That's what I'm going to do. So here I'm going to group them into three. I'm going to solve the parabolic ones. Then after that, I'll solve the hyperbolic. I'll solve the elliptic. Is that okay? So first thing, when a question is given to you, you have to test whether it's hyperbolic or parabolic or elliptic. So let's test for this one. So our A here is what? X squared. Our B is 2xy. Then our C is what? Y squared. Is that okay? So in testing for this, first we have to get our discriminant, which is b squared minus what? 4ac. So b squared is this, which will give you 4x squared y squared. Is that okay? Minus 4. A is x squared. C is what? Y squared. You see, this and that are the same. So when you subtract them, we are going to have 0. And when something is 0, it is what? Parabolic. Parabolic. Is that okay? So this is parabolic. Now that we have this, the next thing that we are going to do is use the characteristics equation. Do you remember the characteristics equation? It was given as dy dx equals b plus or minus square root of what? B squared minus 4ac, all divided by what? 2a. Do you remember this? So this is the characteristics equation. So we are going to substitute the b, the a, and the c into this equation. So I have dy dx equals, now b is what? 2xy. So I'll put 2xy here minus plus or minus square root of b squared. So I'm going to have 4x squared y squared minus 4x squared y squared. And all this is divided by, I hope you understand why I've written this way. Because when I come to this place, the b squared is 2xy. So when I square them, that's what I will get. And the 4ac, a is x squared, c is y squared. So that gives you that. And already we even did it with the, when we are looking for the, whether it's hyperbolic or parabolic. Now after this, over 2a. So 2a, a is what? X squared. So x squared. Is that okay? But remember, whatever that is in the bracket to go to, sorry, the square root to go to 0, the discriminant always be 0 there. So what we have here is 2xy over 2x squared. Is that okay? So my dy dx is equals to 2 cancel 2. X going to x, leaving 1 x. So we have y over what? X. Is that okay? Now for this case, you have to separate them. So the dy will be over y and the x will be over what? X. So we can integrate this. Now if you integrate this, you get ln of what? Y. If you integrate, you get ln of what? X plus the constant c. Now in this case, you can have ln y equals ln c x, they are logarithm and they are multiplying, you get this. Okay. Now let's see something here. It's very important to be doing that. This lane y equals lane. When you take e on both sides, the y will go leaving. The lane will go leaving y equals c x. Now here we want to make c the surface, so our c will be equals to y over x. Now what we do here is that, if you remember, we are going to write this c to be, we let the c to be equals to what? Xi, okay, in terms of x and y. Means that my xi in terms of x and y will be equals to what? Y over x. Now we are dealing with xi and what? Eta. So if I have xi, then I need to get eta. The eta will be in terms of x and y. For me to get eta, I will choose whether x or y, any one of them. So I prefer to use the y. If you remember when we were dealing with the change of variable, I told you. So when you use the y, this is what we are going to what? Get. Is that okay? Okay, so now we have our xi and we have our what? Eta. The procedure in which I followed to get my xi is what I've just gone through with you already. And the eta you will choose, because when you do this, you get only one equation for xi. You won't get for eta, so you choose the eta, whether you pick x or you pick y. But I like using y. Now here, the next thing is that you differentiate. So we are going to have xi. So if I differentiate xi with respect to x, I'm going to have, remember this is constant. It's like when you have 2 over x and you are differentiating it. These two, the x will go to making 2x to the power negative 1, right? Then you differentiate. It's the same thing that is going to what? Happen here. So look, this one, if I differentiate, I'm going to have negative y over s squared. Because this y is constant. Then I'll differentiate the same xi with respect to y. And this is going to give me 1 over x. If you differentiate y, you get 1 over x. Then I'll then differentiate eta with respect to y. That will give me 1. You know, eta with respect to x will give us what? 0. So this is what you're going to get. Now, the next thing that you are going to do is this. You see here we have u x x, u x y, u y y. So you need to differentiate all this. And this, we apply the formulas that I use, okay? But this is very simple. Look, first, you need to get your u x first. Now, for you to get ux, you know it is what? U xi x plus u eta x. Is that okay? But look, xi x has been worked for. This is xi x. When we differentiate xi x, you have negative y. When you differentiate xi with respect to x, you have negative y over x squared. So this place is going to be negative y over x squared u xi. So I'm just replacing the xi here by the negative y over x squared, which we worked for it here. Then plus eta x. Eta x is 0, so 0 times this will go to 0, so we don't need this. So this is what we have. Then go and differentiate it 1, 2. So that's why I'm saying you don't need to put the formula here. Okay. Now this, I will hold this one, which is negative y over x squared. Then I'll differentiate u xi. And you know u xi will be u xi x plus u xi eta x from the table that I used. So if you know you have not watched the other one, go and watch and understand it before you come. If not, you'll be confused. Plus, now I'm done with this. So I will now hold this and I will differentiate this. Remember, I'm differentiating with respect to x. So if I differentiate, forget this become constant. So if I differentiate this 1 over x squared is negative, that will give me positive 2y over s cubed. Is that okay? U xi, because I hold this, then I'll differentiate it. So that's how this thing is going to be differentiated. After we are done with everything, you come back here, wherever you see u x x, you put it there. That's what you're going to do. But so let's multiply this one through, okay? Before you multiply, you know this is xi x. Where's our xi x? Our xi x is negative y over x squared. So we are going to substitute there. We have u xx to be equals to negative y over x squared out. Negative y over x squared u xi xi. Is that okay? Plus eta x. Where's our eta x? Eta x is 0, so everything here will go to 0. So this will be like this. Then plus 2y over x cubed u xi. Is that okay? So in this case, if I multiply this one through, I have my uxx to be equals to negative, okay, negative times negative, that will be y squared over x to the power 4 u xi xi. Is that okay? Plus 2y x cubed u xi. So this will be the formula for the uxx. So it means that when you come here, wherever you see uxx, you are going to put the whole of this one there. Is that okay? Good. So let me write it somewhere here. Uxx here, which is y squared over x to the power 4 u xi xi plus 2y over x cubed u xi. Now, let's move to the next one, which is uxy. Already you know ux to be this. So you are now going to differentiate ux with respect to y. So what is going to happen here is that first I'll hold the negative y over x squared. Then I'll differentiate u xi with respect to y. So that will be u xi xi y plus u xi eta y. Is that okay? Then plus I will then hold this and differentiate this. If I differentiate this with respect to y, it's only the y that it will affect it. So if I differentiate y, that will give me 1. So here will be, instead of like become negative because of the negative here, 1 over x squared u xi. Is that okay? So here, I know my u xi. My u xi is 1 over what? X. Is that okay? So if I do the substitution, I'm going to have uxy equals negative y over x squared multiplied by 1 over y, 1 over x u xi plus eta y. Eta y is 1. Is that okay? So 1 times this will still be u xi eta, like this. So then minus 1 over x squared u xi. So now uxy, if I multiply this 1 by this, I have negative y x cubed u xi xi minus y over x squared u xi eta minus 1 over x squared u xi. Okay, so this is what you are going to get. Is there any like terms there? There's no like term. So it means that my u xy, let me write it here because I'm going to use negative y over x cubed u xi xi minus y over x squared u xi minus 1 over x squared u xi. So I have written this one to here because I will need it. Now, let's clean it. Okay, so we now have uxx here. We now have uxy here. So we now have to look for uyy. So first we have to look for uy, which will be u xi y plus u eta y. So uy will be xy is 1 over x. Okay, so we have 1 over x u xi plus eta y is 1. So we have u eta. So my u y is now going to be, now I'll hold this and okay, let me hold this one first. It's 1 over x. Then let me differentiate this. This gives us u xi xi y plus u xi eta y plus, then I'll hold this and differentiate this. If I differentiate this to give me negative, okay? So negative 1 over x squared u xi, then plus this. For this one, the coefficient of this is 1. So even if I hold 1 and I differentiate this, that is going to give me u eta xi y plus u eta y. Then I'll hold this u eta, then I differentiate 1. If I differentiate the 1 is constant, that will give me 0. 0 times this will be, so I don't need to bring it there. So in this case, my uyy is going to be xi y is 1 over x. So 1 over x times 1 over x, I'm going straight. So if I substitute 1 over x here to 1 over x and 1 over x, that will give 1 over x squared u xi. Is that okay? Okay, let me bring it. If not, people will be confused. So I'm going to have something like 1 over x like this. U xi plus eta y is 1. Have you seen it? So I'm going to have u xi eta minus 1 over x squared u xi. Xi y is 1 over x. So we have plus 1 over x u xi eta. I told you that you can interchange this. Plus eta y is 1. So that will be u eta. So in conclusion, I can have u xi to be equal to, if I multiply this one by this, I'm going to have 1 over s squared, right? U xi. If I multiply this by this, you see I'll get 1 over x u xi eta, and this is 1 over x u xi eta. So that will give me 2 over x u xi eta. Is that okay? Then minus 1 over s squared u xi plus u eta. So this is what I'm going to get for this particular one. So now we have uxx and uxy. So you need to find uyy. Okay, but first you need to find the uy pair, which is u xi y plus u eta y. So we know xi y to be 1 over x. So here will be 1 over x u xi. That's xi y is 1 over x plus eta y is 1. So 1 times this will be u eta. So uyy is now going to, I will hold this. Then I'll differentiate this. That will give me u xi y plus u xi eta y. Then I'll hold this and differentiate this. But remember, this I'm differentiating with respect to y. So if I differentiate, this is constant, that will go to 0. 0 times this is 0, so I don't need to differentiate. Then I'll move to the other side. This is u eta y plus u eta y. If you are confused with what I'm doing here, I mean the formula writing, visit the table. That's what I'm saying, that you need to go and watch that video before you come here. The proof of the canonical forms, the formulas. Now here, xi y is 1 over x, so I'm going to have uyy equal 1 over x times this will be 1 over x squared u xi plus eta y is 1. 1 times this will be 1 over x u xi eta. Xi y is also the same thing, plus xi y is 1 over x, so here it's going to be 1 over x u xi eta, and here eta y is 1, so that will give you u eta, that's plus. So now we also have uyy. Even this and this are the same, so I can write it together. I can write it as 2 over x u xi eta plus u eta. Okay, like this. So now what I'm going to do next is that I'm going to substitute 1, 2, 3 into this formula. Okay, so the first one is x squared bracket open u x x, sorry, Now the uxx is what I have here. Y squared over x power 4. Y squared over x to the power 4 u xi plus 2y over x power 3 u xi. Then here is minus. So already I have 2x out there. So plus 2xy bracket open. Uxy I have minus y over x cube. Minus y over x cube u xi minus y over x squared u xi minus 1 over x squared u xi, you close bracket. Then lastly, you have uy, the uyy that is plus. The uyy is having y squared there, so bracket open 1 over x squared u xi plus 2 over x u xi plus u eta. Is that okay? Good. So now let me open this bracket. If I multiply this by this, what happens? I'll have y squared over x power squared. The square will take care of one of the x, two of the x. Okay. Even u xi plus 2y over x u xi. When you multiply this, that's what you get. Positive multiply negative becomes negative. So what happened here is I'm going to have 2y squared, okay, over x squared u xi. This multiplying this also become negative. I'm also going to have 2y squared over x u xi eta minus 2y over x squared u xi plus this multiplied by this, I have y squared over x squared u xi plus 2y squared over x u xi eta plus y squared over u eta is equals to what? 0. So let me bring it up here. Oh, let me clean here. Let's see. This is u xi, right? We also having u xi here. This and this are the same. So I can add this to get 2y squared over x squared. This and that. Which can cancel this one. Have you seen that? So when I add these two, it will cancel this. Is that okay? Then you also have 2yx u xi. The negative 2yx. What happened in this square here? There shouldn't be any square. Okay. Let's see. I think that's 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So one of this x will cancel one of these, leaving one x. So it's just x. Is that okay? Good. Then, so it means that this will go with this one. Then we have y squared, x squared. Okay, this one has already been cancelled out. We have negative 2y squared over x, positive 2y squared over x. This and that are the same, they will go, leaving only this. So we have y squared u eta equals 0. You divide here by y squared, here by y squared. So it means that my u eta is equals to 0. Therefore, the canonical form of the PDE is u eta is equals to what? 0. So this is all that we needed. We have struggled like that. So is that okay? So thank you very much for watching. Thank you very much. Let's move to the next example. Okay, now let's look at how to write the canonical form of this. Solution our A is what? 1, B is equals to -4, C is equals to +4. So first, let's test whether it's parabolic, hyperbolic, or elliptic. So that's b squared minus 4ac. So in this case, our b is that. So negative, if I square this, that will be 16 minus 4 multiplied by 4 multiplied by 1. This will give you 0. So since it's giving you 0, that is what? Parabolic. Is that okay? So once it's parabolic, You then write the characteristics equation. And that one is what? Dy dx is equals to b plus or minus square root of b squared minus 4ac all divided by 2a. So dy dx equals b here is negative 4. I'm going to have negative 4 plus or minus square root of 16 minus 16, okay, divided by 2 times 1. So my dy dx is equals to, this will be 0. 2 can go in negative 4, negative 2. So I have my dy equals negative 2x dx. So I will integrate both sides. This will give us y equals negative 2x plus c. Is that okay? So my c will be equals y minus, plus 2x. So you see that let xi to be equals to c means that xi is equals to y plus 2x. So if xi equals y plus 2x, then xi x is going to be 2, xi y is going to be 1. Now you have to let eta to be equals to what? Y. So that, let me do it here. Xi y is 1. So if you let eta to be equals to y, my eta y is what? 1. Eta x will be 0, so there's no need for me to write. Okay, so now that I have this, what I'm going to do is that I have to find ux x. So for you to find ux x, you know that first you have to find ux first, which is u xi x plus u eta x. Xi x is 2. So I'm going to have ux equals 2 u xi plus eta x will be 0 because let me write it here. Eta x is 0. So everything there goes to 0. So my uxx becomes whole 2. Differentiate this. This will be u xi x plus u xi eta x. If I hold this and differentiate, this is constant. It will be 0. 0 times this will be 0. So there's no need for me to continue. Now, xi x is 2. So if I put 2 here, 2 times 2 is 4. So I have uxx equals 4u xi. Eta x is 0. So there's no need to bring that one. Everything will be 0. Now, after that, I move to u xy. See, I have xy here. So already I have ux. So I'm going to base on this to differentiate. So 2 brackets open u xi y because I'm differentiating with respect to x. U xi eta y. So my uxy equals, I will not bother myself to differentiate to 2 is constant, so it will be 0. 0 times this is 0. Xi y is 1. Eta y is also what? 1. So it means that you're going to have 2u xi plus 2u xi eta. So this is what you're going to get. Is that okay? Now from here, we are done with that one too. So we are now moving on to the other one. So let me write the answers here. My uxx is 4u xi. My uxy is also 2u xi plus 2u xi eta. So these are the two things. So now I need to find u y. That u xi y plus u xi u eta y. So my xi y is 1, eta y is 1. So I have u y to be equal to u xi plus u eta equal 1 times 1. That will give you this. So here, let me clean the top one. So here, when I come to the top part, that means I'm going to have my uyy equals to differentiate this one. That'll give you u xi y plus u xi y plus, then you differentiate it. This will give you u xi y plus u y. So this is what you're going to get. So my u xi equals xi y is 1. Xi y is 1. So this will give me u xi. Eta y is also 1. So this will give me u xi eta. Xi y is 1. So this will also give me u xi eta. You can interchange this. Plus u eta. Because this one is also 1. So at the end, this is what I'm going to achieve. I'm going to achieve this. Uyy is going to be this. U xi plus this and that are the same. So that will be 2 u xi eta plus u eta. So this is what I'm going to achieve at the end. Let me clean this sign. So now I have my uxx, my uxy, then uyy. So I'm going to substitute everything here. Uxx has no coefficient. The coefficient there is 1. So 1 times this will give us the same thing. So this gives us 4 u xi. So minus, okay, minus 4 uxy, and this is our uxy, 2uyy plus 2 u xi eta, 2 u xi plus 2 u xi eta, 2 u xi plus 2 u xi eta. Then I'm done with that one. Then I go to plus 4 uyy, which is here. So that u xi plus 2 u xi eta plus u eta equals u to the power y. Now, let's open the bracket. If I open the bracket, I'm going to have u xi 8 u xi minus 8 u xi eta plus 4 u xi plus 8 u xi eta plus 4 u eta equals e to the power y. You see, this and that are the same. They will go. This, if I add this to this, that will be 8. So that will also cancel with this. Okay. Leaving 4 u eta equals e to the power y. But remember, you have to change everything to xi and eta. Remember that we said that our eta is what? Y. So wherever you see y, you can put eta there. So we have 4 eta equals e to the power eta. If I divide both sides by 4, my final answer is going to be u eta is equals to 1 over 4 e to the power eta. So this becomes my canonical form. Is that okay? Very good. Thank you very much for watching. Please subscribe and share, and also practice more.